has started collaborating with Brian's team at Facebook, and I'm going to talk a little bit today about some of the things that we're doing together. I was excited to come talk at scale because to adapt their business at an even faster rate. They have to change, adapt, but they also get the benefit of using cloud technology. And working at Google, I have to see a great way to learn, right, to go through the code review process. So what's it like to be a Google engineer? We've heard a little bit about some of the systems, and I think this is really important because it's a level of unparalleled sort of access that is sort of transmitted through our entire culture.
While the modern cloud is often envisioned as an invisible virtual network, its physical reality is anchored to the ocean floor by vast networks of fiber-optic cable. Global software development depends heavily on centralized repositories that require continuous transoceanic data transmission to synchronize.
First one is physical infrastructure, or our cloud. The second one is our code, or our products. And the third one is the people, right? The humans writing the software. So we have to think about the humans. So today I'm going to talk a little bit about the systems that enable engineers to do work at Google. I'm going to also talk about the systems that Google is bringing out into the cloud, just as other service providers, cloud service.
A kinetic disruption to these links does more than halt user applications. It halts the deploy pipelines responsible for critical security in the event of subsea infrastructure sabotage. Automated systems immediately attempt to reroute petabytes of traffic through constrained alternative pathways,
just as other service providers, cloud service providers, are doing. And then I'm going to talk a little bit about how we maintain our engineering culture. And a lot of this has to do with the tools that we bring into the engineering community. So innovation at Google. From search and ads and Gmail and Android, I heard some great announcements at the keynote this morning. Google's mission is very broad in scope.
When primary oceanic trunks go offline in milliseconds, the sudden redirection of data attests the limits of failover capacity. The modern cloud operates on the premise that physical distance is irrelevant, yet its structural reliance on instant synchronization makes physical breaks devastating.
Announcements at the keynote this morning. Google's mission is very broad in scope. We're working on projects from self-driving cars to bringing infrastructure and access to users in remote areas of the world. And we have a high tolerance for failure and risk-taking. And this directly translates to the types of tools that engineers need to do their work, right? We believe in empowering teams so that they can make decisions and they can take risks and they can use experimentation and prototyping.
Without physical transport corridors, automated cloud platforms are forced into erratic rerouting choices that can worsen the initial outage. The immediate aftermath of a subsea cable failure triggers massive automated efforts to migrate workloads to surviving regional data centers.
We believe in empowering teams so that they can make decisions and they can take risks and they can use experimentation and prototyping to test out and vet their ideas. So I believe we're able to innovate the way that we do at companies like Google and Facebook and many other companies in the industry because we can use cloud services now in new and interesting ways. And as developers, we're writing code and we're benefiting from the fact that cloud services, they're taking on a lot of.
This sudden deluge of redirected traffic creates congestion bottlenecks that can disrupt previously stable, unaffected regions. The high efficiency of modern cloud providers is achieved through shared global backbones, which unfortunately allows local disruptions to propagate globally.
Benefiting from the fact that cloud services, they're taking on a lot of the operations that maybe we had to juggle between writing code and performing those operational tasks. So for the past 15 plus years, we've been working on building the most reliable, efficient, physical infrastructure and software infrastructure built on top of that physical infrastructure so we can all benefit from it. But what is the cloud platform? I mean,
highly integrated management pipelines mean a localized physical, break and destabilize telemetry metrics across the entire global network. When subsea connections fail, monitoring systems detect the drop in throughput and automatically initiate massive auto-scaling events.
Platform. I mean, today I'm going to talk a lot about Google because I work at Google, but we all know there are many other cloud providers out there. But really the cloud is about us at Google productionizing the things that we are using, tools, processes, systems that we built all of our Google products on top of. And Google and developers are using those directly. So we're making it possible to use our infrastructure very efficiently and for anywhere from startups to...
This immediate surge in compute demand on remaining regions can result in severe resource exhaustion and localized power grid stress.
Scale that we're talking about, and that we want to bring those tools out into the engineering community. So before I move on, how many people... I asked for the tech lead manager point because I think managers and leadership should also really care about their developers' productivity. We organize software development at Google. We try and make it fast, and we try and make it fun too. So from the time that engineers sit down to write code, to search it, to version it, to build and test and reliably release it, developer tooling is responsible for making engineers happy. And our goal is just to make developers' lives easier so we can all, as developers, focus on code and do the things that we love. But it's not just about Google developers. It's about the entire engineering community. So that
in a severe subsea fiber outage, synchronization delays expand from milliseconds to hours, bringing remote deployment workflows to a
developers. It's about the entire engineering community. So that scale that I just talked about, Google's been operating these large-scale systems for many years, and we've developed some tools to operate, diagnose, and understand these services at a very large scale, almost absurd. And we've learned a lot of lessons, and so what we're doing now is we're trying to bring the lessons that we've learned and the tools that we've developed out into the engineering community. So we're
locating a physical fault along thousands of miles of deep-sea fiber-optic cable is a slow and technically demanding challenge.
Google, I was really impressed with all the investment that had gone into developer tooling because I was used to very long build and test and release cycles. And
experienced security analysts note that state actors target deep oceans owned specifically to delay repair efforts by weeks. In the initial moments of a physical fiber sever, automated monitoring dashboards flood on-call engineering teams with ambiguous alerts.
Level of happiness had declined because they wanted things to be instantaneous. And I think that's the right expectation to have, right? So very few people raised their hands. I think a couple people in the front that they couldn't see all the people behind them that were not happy with their developer tools. I just think this is the way it is, right? If we keep making improvements, then the expectation and the bar keeps being raised. And I actually like that. So, why talk about, building code quickly? Why is that important? Well,
system logs show that standard software monitoring systems are poorly equipped to distinguish between bad code deployments on seabed-level kinetic strikes. As global trunk line congestion increases, localized content delivery networks are cut off from core databases and begin serving outdated cache files.
Why talk about, building code quickly? Why is that important? Well, when you can imagine that you have instantaneous feedback, right? Your velocity and your speed is just on a whole nother level.
Seabed level hardware disruption eventually manifests as frozen user interfaces and connectivity failures on everyday consumer applications. Subsea cable disruptions delay security telemetry data, creating blind spots for security operations centers.
Easily identify failures and find culprit changes. And they can easily select from frequent green builds because we show all the testing results together. And we also integrate our testing tools with our release management tools. So again, we're trying to have that very fast build, test, and release cycle. In addition, we do a lot of automated web testing and mobile testing, millions of test cases a day over 20 plus some odd OS and browser combinations.
Threat actors can coordinate physical cuts with logical campaigns, using the physical blind spot to establish access inside isolated systems. During a transoceanic cable partition, the monitoring tools used to track infrastructure health are themselves cut off from remote nodes,
are really making sure that quality code is going out the door. So what does Google do internally to manage our code? Well, we do have a single monolithic tree with very fast access for developers. And that means development on one branch with submissions ahead. We integrate early and often, and developers can view, modify, and experiment with code across the repo. And I think this is really important because it's a level of unparalleled sort of access.
This leaves operations teams with highly fragmented visibility, making it difficult to verify system states across different continents. Modern economies treat global bandwidth as an infinite, cheap commodity, overlooking the vulnerability of the glass fibers supporting it.
And I think this is really important because it's a level of unparalleled sort of access that is sort of transmitted through our entire culture. And we all know developers love languages. So C++, anyone? No C++ program? Okay. So yeah, we support C++ and Java and Go and Python and a variety of other languages. So developers can use what they're good at. And I just wanted to mention Rachel Potvin.
When these lines fail, available bandwidth instantly becomes a scarce resource, often prioritized for national security communications. Architectural resilience is not achieved simply by replicating virtual instances. It requires genuine physical routing diversity.
And I just wanted to mention Rachel Potvin, who is here, is going to be talking in detail about Google's code management later on today. So definitely go.
Until the physical vulnerability of subsea pathways is addressed, virtual platforms remain built upon highly fragile foundations. Until the physical vulnerability of subsea pathways is addressed, virtual platforms remain built upon highly fragile foundations.